students, welcome back to the channel. This is Madhuri, your chemistry femta. Today I have come with another video lecture on some basic concepts of chemistry. Already we have completed 2 video lectures in which we have discussed matter, states of matter, classification of matter in detail, in which we have come across pure substances, mixtures, elements, compounds. Then we have discussed properties of matter and their measurement in the second video, and then we have also discussed some of the terms such as mass and weight, volume, density, temperature. Now in this video we are going to learn about uncertainty in measurement, which is the 4th topic of the chapter, that is uncertainty in measurement. See students, this is very important topic as all the calculations regarding chemistry are based on this important topic. So if you understand this topic, all the calculations which we will have in future will be easy for you to do it. Okay, under this uncertainty in measurement, we are going to learn about scientific notation. Under scientific notation, we will learn multiplication and division of exponential numbers. Multiplication and division of exponential numbers. What is meant by exponential numbers we are going to discuss. Okay. Next we will learn about addition and subtraction of exponential numbers. Exponential numbers. Okay, so first we will learn about scientific notation, how to write a scientific notation. Then we will learn the various mathematical calculations such as multiplication, division, addition and subtraction of exponential numbers. Then we will learn about significant figures. Under significant figures also we will learn how to add, subtract, multiply and divide significant figures. And at the end we are going to learn about dimensional analysis. See, the terms might be very new to you, but if you observe this video, watch this video carefully without skipping it, you will be very much familiar to these terms, and all the further chemistry calculations also you will be able to do very easily. So this video is very important, and if you understand all the calculations, if you like the content of the video, please do like, share, subscribe and comment in the comment sections about your opinion of the video, whether you like the video or you want to suggest any improvements also, you can comment it. Okay, so did you understand? So today we are going to learn about uncertainty in measurement. Under that we will learn about scientific notations, how to add, multiply, divide and subtract exponential numbers. Then we will learn about significant figures, how to add, subtract, multiply and divide significant figures, and then we will learn about dimensional analysis. So let's start the video. Okay students, the first topic that we are going to learn about is the scientific notation. See students, you already know what is chemistry. Chemistry is nothing but it is the study of atoms and molecules. So in chemistry sometimes you will have to deal with numbers as large as 602, 200, this number is very large, isn't it? And this is for the molecules of, this number is for the molecules of 2 grams of hydrogen gas. So in chemistry sometimes you will have to deal with such a big number for small molecule, that is H2. And sometimes you will have to deal with extremely small numbers such as grams, and this is the mass of hydrogen atom. See, such a small number, isn't it? But every time you cannot write, you have to remember how many zeros you have to write, isn't it? So every time writing the number in this format is very, very difficult. So, and writing the number itself is difficult, and moreover you have to perform the mathematical calculations on this number. How difficult it is? What are the mathematical operations that you will have to perform? Sometimes you will have to add, sometimes you will have to subtract, sometimes you will have to multiply, and sometimes you will have to divide. It is very, very difficult, isn't it? So, in order to solve this problem, scientists proposed a method known as scientific notation. Now, what is scientific notation? Scientific notation means any number can be represented in the form of n into 10 to the power small n, capital N into 10 to the power small n, where capital N stands for the digit term. Okay, it stands for the digit term which varies from 1.00002 to 9.999 and so on. And small n stands for the exponent. And this exponent can have positive value or a negative value. Okay, so this is the scientific notation, or it is also known as exponential notation. So, in exponential notation, how will you represent a number? You will represent a number in the form of capital N into 10 to the power small n. In this, what does capital N stand for? It stands for the digit term, and the value of this digit term varies from 1.000 and so on to 9.99999 and so on. And small n stands for the exponent. Let us see one example. Suppose I give you a number 232.508. Suppose this number you have to represent in the form of an exponential form. How will you write it? See, it is convenient if we have one number only before the decimal. Okay, so if you want to have one number before the decimal, what you have to do? You have to move this decimal to 1 and then 2. 2 places. Towards which side have you moved? Towards the left side. So 2 point, write the remaining number 32508. There is no more decimal here. We have moved 2 places to the left. So since we have moved 2 places to the left, the exponent is 2. Okay, just 2 represents plus 2. If there is no sign before the number, it indicates a plus. If there is a minus sign, must and should, you should indicate. If it is a plus sign, if you don't indicate also, no problem. Did you understand? Means what? For our convenience, before the decimal, only one number we will keep. And if we move the decimal 2 places towards the left, then the power will be plus 2. Let us take one more example. 0.00016. What I have told, before the decimal we should have only one number. Here one number only is there, but it is 0, which has no value. So what we will do? We will move it to the right side. 1, 2, 3, 4. Okay, now write the number. What is the number now? 0 has no value, no? So 1.6 into 10 to the power. How many places we have moved? 1, 2, 3, 4 places we have moved. But we have moved towards right side. So it is -4. Very important. You have to remember this sign here. You have to write this sign here. Otherwise, the whole meaning of the number will change. Did you understand? If you move the decimal towards left side, exponent will have a positive sign. If you move the decimal towards the right side, exponent will have a negative sign. And remember, it is always convenient if you have only one number before the decimal. Okay? Now let us see the calculations of these scientific notations. The first mathematical operation that we are going to learn is the multiplication. Let us see how multiplication of exponential form numbers can be done. Let us take an example. 5.6 into 10 to the power 5 into 6.9 into 10 to the power 8. So these are given in the exponential form. It has a number, capital N. Here 5.6, here capital N is 6.9. Here small n is 5 and small n is 8. So this is an exponential number. This is also an exponential number. Now, when you have to multiply the numbers in the exponential form, you will have to add the powers. Remember, when you have to multiply the numbers in exponential form, you must add the numbers. So you can write this as, first we will write only the capital N terms, that is 5.6 into 6.9. We have left the power terms. Next, into 10 to the power. What are the power here? 5 plus 8. Okay. So 5.6 into 6.9 comes to how much? 38.64 into 10 to the power 5 plus 8 is how much? 13. Okay. Now what I have told, before the decimal only one number should be there. So we have to move this decimal point to one number to the left. Okay. When we move to the left, what happens? The power is positive. So 13 plus one number to the left. So 3.8064 into 10 to the power, 864 into 10 to the power 14. Did you understand? When you do multiplication for the exponential numbers, you have to add the powers. Only this one term, if you remember, remaining all will be easy. So what is the first step? First step is you have to multiply the n terms, capital N terms. See here. The number which is given is 5.6 into 10 to the power 5. Okay. What is the formula? N into 10 to the power small n. So here capital N is 5.6, small n is 5. Okay. So first you have to multiply the capital N terms. So 5.6 into 6.9. Next you have to add the power terms, 5 plus 8. 5.6 into 6.9 is 38.64 into 5 plus 8 is 13. Now we know the rule, before the decimal it is convenient if we have only one number. So we have moved to the left. Since we have moved to the left, the power is positive plus. So 13 plus 1 number we have moved. So 14. Answer is 3.864 into 10 to the power 14. Okay. If you still have any confusion, please rewind it and watch it again. Okay. Let us see one more example for easier understanding. 9.8 into 10 to the power minus 2 into 2.5 into 10 to the power minus 6. Okay, what we have to do first? We have to multiply the n terms. N terms are 9.8 here and 2.5 here. Leave the 10 to the power terms. Only before 10 to the power whatever number is given, you have to multiply them first. 9.8 into 2.5 into 10 to the power. What we have to do? We have to add the powers. Why we have to add the powers? Because we are multiplying. When you are multiplying, you have to add the powers. What are the powers? Minus 2 plus minus 6. Okay, minus 2 plus minus 6. Okay, minus 2 plus minus becomes minus. Okay, plus and minus becomes minus. Minus minus becomes plus. Plus plus becomes plus. You have to remember this. Okay, here what is given? Plus into minus is minus. Minus into minus plus. Plus into plus is plus. You have to remember it. Okay, now here what are the powers? Plus into minus. So minus 6. Okay, so minus 2 and minus 6, if you add, what you will get? Minus 8. 10 to the power minus 8. Here what is remaining? 9.8 into 2.5. What is 9.8 into 2.5? 24.50. Now what is the rule? What is the rule? Before the decimal only one number should be there. Here we have two numbers. So we will move one number towards left. When we move one number towards left, it is positive. So minus 8 plus 1. Minus 8 plus 1. So minus plus what becomes? Minus. So 8 minus 1 is how much? 8 minus 1 is 7. What is the bigger number here? 8. So bigger number sign you have to put here. Okay? You have to put here the bigger number sign. Did you all understand? Let me tell you once again. First you have to multiply the n terms. That means before 10 to the power whatever number is there, that you have to multiply. 9.8 into 2.5, you will get 24.50. Okay, next, now coming to the powers. When it is multiplication, you have to add. So minus 2 plus minus 6. Plus minus becomes minus. So minus 2 minus 6. When it is 2 minus, what you have to do? You have to add. So 6 plus 2 will be 8. What is the bigger number here among 2 and 6? 6 is the bigger number. What is its sign? Minus. So here you will have to put the minus sign. Next, in the answer we have 24.50, but before the decimal only one number should be there. So we will move one place towards left. When we are moving one place towards left, power will be positive. Plus, only one place we have moved now, so plus 1. Now minus plus becomes minus. 8 minus 1 is 7. Among 8 and 1, which is the bigger number? 8. Its sign is minus. So in the answer you have to put the minus sign. So 2.450 into 10 to the power minus 7 is the answer. Okay, did you understand? Now let us see the division. Let us take an example. 2.7 into 10 to the power minus 3 by 5.5 into 10 to the power 4. So you have to divide these two numbers and you have to tell the answer. First, what is the rule? You have to divide the n terms, capital N terms. What are capital N terms? The number before 10 to the power. Okay, so 2.7 divided by 5.5 you have to do first. Next, 10 to the power minus 3, and this 4 went from the, this is what, numerator, this is denominator. When any power goes from denominator to the numerator, it acquires the opposite sign of its original sign. Means what? When this, what is the sign of this power here? Plus. I told you, when there is no symbol before the number, it indicates a plus sign, isn't it? It indicates a plus sign. So when this plus 4 from the down, when it goes up, it becomes minus 4. What does it become? Minus 4. Okay. So 2.7 divided by 5.5 will be 0.4909 into 10 to the power. Minus will be plus. 3 plus 4 is how much? 7. Among 3 and 4, which is the bigger number? 4. What is its sign? Minus. So in the answer you will have to put the minus sign. Now see here, what is the rule? Before the decimal only one number should be there. That rule, it is satisfying, but that number is 0. So what we will do? We will move 1 point to the right. We will move 1 point to the right. When we are moving towards the right, the sign of the power will be minus. Because we have moved 1 point towards right, so minus 1. So 4.909 into 10 to the power. Minus is plus. 7 plus 1 is 8. What is the bigger number here? 7. What is its sign here? Minus. So in the answer you will get the minus sign. Okay. So answer is 4.909 into 10 to the power minus 8. So only one thing you have to remember. Whenever you move the number from the bottom to the top, it will acquire the opposite sign. Okay. This is about the division. Now let us see the addition. Let us take an example. 6.65 into 10 to the power 4 plus 8.95 into 10 to the power 3. Okay. Now remember, one important rule which you have to remember for addition and subtraction is that the power numbers should be same. Okay. So first you have to convert the number in such a way that the power numbers are same. Here power is 4. Here power is 3. So either you have to convert 3 to 4 or you will have to convert 4 to 3. Let us convert 3 to 4. Now what is the number here? Number which we have to convert is 8.95 into 10 to the power 3. Now this 3 has to turn into 4. If this 3 has to turn into 4, what we have to do? We have to add plus 1. When will be the power be plus? When we move the decimal towards left side. So we will move the decimal towards left side. How many places? Only one place. So when we move one place to the left, this number becomes what? 0 point. Because here there is no number, so we will take 0. 0.895 into 10 to the power 4. Did you understand how we converted 3 to 4? Now put this number here. So what will be our actual sum? 6.65 into 10 to the power 4 plus 0.895 into 10 to the power 4. Okay. Now what we have to do is, first we have to add the terms which are given before the power numbers. So 6.65 plus 0.895. You will have to add first into 10 to the power 4 is common for both of them. Okay. Now when you add 6.65 and 0.895, what is the answer that you get? 7.545. Okay, so answer is 7.545 into 10 to the power 4. Okay students, did you understand? So what is the rule that you have to remember? Whenever you are adding, you have to first convert the numbers having the same power. Okay, because here first it was 4 and then it was 3. So first we converted 3 to 4 and then we performed the addition. Did you all understand? Now students, now coming to the subtraction. Did you understand how to add the exponential numbers? Now let us see the subtraction. 2.5 into 10 to the power minus 2 minus 4.8 into 10 to the power minus 3. Students, remember here also the same rule applies. What is the rule? Whenever you add or subtract the exponential numbers, first you have to equate the 10 to the powers. Here it is 10 to the power minus 2. And here it is 10 to the power minus 3. So first we have to either change 2 into 3 or we have to change 3 into 2. Let me change 3 into 2. What is the number given here? 4.8 into 10 to the power minus 3. Now I need here minus 2. So what I have to do? I have to add plus 1. Minus plus is minus. 3 minus 1 is 2. So minus 2. So if plus sign has to come, to which side should I move the decimal? Left side or right side? Yes, we have to move towards left side. When we move the decimal 1 point towards left, the new number is 0.48 into 10 to the power minus 2. Okay, so now let us write here 2.5 into 10 to the power minus 2 minus 0.48 into 10 to the power minus 2. Here first we have to subtract the capital N terms. So 2.5 minus 0.48 into 10 to the power minus 2 is common for both. Okay, now when we subtract 2.5 minus 0.48, we will get 2.02. Okay, so 2.02 into 10 to the power minus 2 is our answer. Did you understand? Only one thing you have to be careful is the power numbers. For addition and subtraction, first you have to see whether the power numbers of both the given numbers are same or not. If they are not same, then first you have to equate it and then perform the operation. Okay. Now comes the next topic, that is significant figures. Let us see what is meant by significant figures. So students, our next topic is significant figures. Now every experimental measurement that we take in the laboratory has some amount of uncertainty in it. It is not accurate. And this uncertainty is mainly because of two reasons. Because of the limitations of the measuring instrument. Because of the limitations of the measuring instrument that we are using to take the measurements, or it might be due to the skill of the person who is involved. The skill of the person who is involved. Okay, so because of these two reasons, the measurements that we take in the laboratory has some amount of uncertainty. For example, suppose we are measuring the mass of an object by using two instruments. One is a platform balance and another one is analytical balance. On platform balance, suppose we get the mass of an object to be 9.4 grams. On analytical balance, we might get it as 9.4213 grams, and this is slightly higher than the mass that we have obtained through the platform balance. Okay, now this is indicated as uncertainty. That means up to 9.4 it is fixed, because by using both the instruments we got 9.4 grams as the mass, but this 213 digits which are there at the end, this is uncertainty in the measurement, and this uncertainty can be indicated by using significant figures, by using the significant figures. So because of this we have to learn about significant figures. Now what is meant by significant figures? Let us see. What is meant by significant figures? Why studying about significant figures is important? Because if we know about the significant figures, then only we will be able to tell up to what level the measurement that we have taken in the laboratory is uncertain. Now what is meant by significant figures? Significant figures are nothing but the meaningful digits which are known with certainty plus 1 which is estimated or uncertain. What is meant by significant figures? Significant figures are nothing but meaningful digits which are known with certainty plus 1 which is estimated or uncertain. Let us try to understand this. Now this uncertainty is indicated by writing certain digits. And the last uncertain digit. Feeling little bit confused? Let us take an example. For example, some experiment we have performed in the laboratory, and the result we got it as 11.2 ml. Here 11 is certain, whereas 0.2 is uncertain, and uncertainty may be plus or minus 1. We do not know how up to what level it is uncertain. Because we do not know, we will estimate it to be plus or minus 1. Okay, so significant figures are the meaningful digits which are known with certainty. Here the meaningful digits known with certainty are 2. 11, 1 and 1, 2. Plus 1 which is estimated or uncertain. This is the uncertain number. Did you understand significant figures? Significant figures involves two types of numbers, certain and uncertain. Certain means we know definitely, and uncertain will be the small error in the measurement. Okay, now there are some rules for determining the significant figures. Let us see what are those rules. Now coming to the rules for determining the significant figures. I already told you significant figures involves two types of numbers, certain numbers and uncertain numbers. Now let us see the rules for determining the number of significant figures in a given number. There are mainly 5 rules. Let us look into them one by one. The first rule is all non-zero digits are significant. all non-zero digits. All non-zero digits are significant. Let us take an example. 285 centimeter. Here the number of significant figures are 3. 2, 8 and 5. Here number of significant figures are 3. One more example. 0.25 ml. What is the rule? Non-zero digits. So here you should not consider this one. You will consider only 2 and 5. So this number has 2 significant figures. Okay. Now second rule. First rule, is it clear? All non-zero digits are significant. Second rule is zeros preceding to first non-zero digit are not significant. Means zeros preceding to first non-zero digit are not significant. They only indicate the position of the decimal point. Now suppose let us take an example. 0.03. What is the rule here? Zeros preceding to first non-zero digit are not significant. Here what is the non-zero digit? 3. So zeros preceding means before. Before 3, whatever zeros are there, they are not significant. So in the number 0.03, the number of significant figures is only 1. Let us take one more example. 0.0052. What is the rule? Zeros preceding to first non-zero digit. Here 5 is a non-zero digit, and 2 is also a non-zero digit. But 5 is the first non-zero digit. So zeros preceding to first non-zero digit are not significant. So these 3 zeros are not significant. This number has only 2 significant figures. Okay. Now coming to the third rule. Third rule is zeros between 2 non-zero digits are significant. Zeros between 2 non-zero digits are significant. Let us take an example. 2.005. Actually, what did we learn? Non-zero digits are not significant. We learned. Zeros are not significant, we learned. But this rule tells us that if zeros are present in between 2 non-zero digits, then they are significant. Okay, if zeros are present between 2 non-zero digits, they are significant. So this number has 1, 2, 3, 4. 4 significant figures. Okay. Now coming to the fourth rule. Zeros at the end or right side of a number are significant provided they are on the right of a decimal point. Zeros at the end or right side of the number, right side of the decimal, are significant. Let us take an example. 0.200. Actually, zeros are not significant, no. But if these zeros are present at the end or towards the right side of the decimal, then they are significant. Then they are significant. So this has 1, 2, 3, 4. 4 significant figures. Okay, suppose if there is no decimal point, then terminal zeros have no significance. Suppose you take 100, there is no decimal point. So these 2 zeros have no value. This number has only 1 significant figure. Okay, Suppose I put a decimal 100.0, then all these zeros will gain significance and this number will have 1, 2, 3 and 4. It will have 4 significant figures. Okay, so if there are these kind of numbers, it is better we represent them in the exponential form. That means suppose 100 is represented as 1 into 10 to the power 2. Why 10 to the power 2? Because we have two zeros and this number has only one significant figure because there is no decimal. 1.0 into 10 to the power 2. Then this will have, here there is a decimal, so this 0 will also gain significance and this number will have two significant figures. Suppose I write 1.00 into 10 to the power 2. Now since there is a decimal, all the three digits have significance and the number of significant figures in this number will be 3. Okay, now coming to the last rule, that is counting the number of objects has infinite significant figures. Why? Counting the number of objects has infinite significant figures. Can you tell why? Because these are exact numbers and they are represented by writing infinite number of zeros. Suppose there are two balls. These two balls can be written as 2.00. How many zeros ever you put, it will have the value of only 2. And how many zeros? Because there is a decimal here, all these zeros will be significant. So the number of significant figures is infinite. But students, here you have to remember one important note. In scientific notation, all the numbers are significant. In scientific notation, all the numbers are significant. Just now we have discussed, no? What is that? Suppose the number is 4.01 into 10 to the power 2. All these three numbers are significant. So number of significant figures will be 3. One more example, 8.256 into 10 to the power minus 3. Here there are 4 numbers before the power. So all these numbers are significant figures. Number of significant figures will be 4. Now let us quickly recap what are the rules for determining the significant figures. First rule is all non-zero digits are significant. That means except 0, remaining all the numbers are significant. Second rule is zeros preceding to first non-zero digit are not significant. They tell us only the position of the decimal point. Third rule is zeros between two non-zero digits are significant. So if there are two non-digits and in between there are zeros, then all those zeros will be significant. Fourth rule is zeros at the end or right side of the decimal are significant. But if there is no decimal, then those zeros are not significant. Next, counting numbers have infinite significant figures. And one note that we have seen is scientific notation. In scientific notation, all the numbers are significant. Okay, now let us move to the next topic. Students, whenever we talk about measurement, we usually come across two terms. First one is precision and second one is accuracy. So before moving further, we need to know what is meant by precision and what is meant by accuracy. Okay, first let us see precision. Precision means it refers to the closeness of various measurements for the same quantity. Closeness of various measurements for the same quantity. That means for the same quantity, if you take 2 or 3 measurements and they are very close to each other, that means the measurements which you have taken are precise. Now coming to accuracy. What is meant by accuracy? Accuracy means it is the agreement of a particular value to the true value of the result. Agreement of a particular experimental value to the true value of the result. Feeling little bit confused? Let me take an example and explain it more clearly. Suppose the true value is, means the actual value is of some object is 2.00 grams. And there are 3 students which are performing the experiment in the laboratory and they are measuring the weight of that object using an instrument and they have taken 2 measurements each. Suppose student 1 got the measurements, student A got the measurements as 1.95 and 1.93. Okay, the average of these 2 measurements will be 1.94. Now see, 1.95 is close to 1.94 and 1.93 is also close to 1.94. That means these 2 measurements are precise. But they are not accurate because the true value is 2.00 grams. Now suppose there is a student B and his values are 1.94 and 2.05. The average of these 2 measurements will be 1.995. Now see, this 1.94 is much smaller than 1.995 and this 2.05 is much greater than 1.995. So these measurements are not precise and they are also not accurate because our true value is 2 grams. Now suppose there is a student C and his values are 2.01 and 1.99 and his average is 2.00. Now these 2 measurements, see, 2.01 is close to 2.0 and 1.99 is also close to 2.00. So these are precise and they are also accurate because these 2 are very much close to the true value. So these are also accurate. Did you understand? Precise means the 2 measurements or whatever number of measurements you are taking, if they are close to each other, then they are precise. If those 2 measurements are close to the true value, then they are accurate. Okay? Now let us see addition and subtraction of significant figures. First, let us see addition. Suppose we have 3 significant figures, 12.11, 18.0 and 1.012. Its sum will be, just simple addition, you will get 31.122. Now see, this is not the answer. 31.122 is not the answer. The answer, when you are writing the answer, you have to keep 1 point in your mind. Suppose here after decimal how many numbers are there? 2 numbers. Here after the decimal 1 number. Here after the decimal 3 numbers. Among 2, 1 and 3, which is the least one? 1. So our answer also should have only 1 number after the decimal. So our answer will be 31.1. Okay, this is an important rule which you have to remember. The answer should not have more numbers than the numbers which are given in the question. Same rule applies for subtraction also. Okay, now coming to multiplication and division of significant figures. multiplication, and division of significant figures. Suppose you are given the number 2.5 into 1.25. The answer will be 3.125. Here also the same rule applies. Here after the decimal only one number is there. Here after the decimal two numbers. The smaller one is 1. So our answer also should have only one number after the decimal. So the answer is 3.1. Okay, but now you have to learn about some rules here also. Let us see what are those rules. Rules for limiting the number. Means, suppose just now we have seen after the decimal how many numbers should be there. So to decide how many numbers should be there and which number should be there, we have mainly three rules. Suppose if the rightmost digit which has to be removed, rightmost digit which has to be removed is more than 5, less than 5, or equal to 5. Then what we have to do, let us see. If the rightmost digit which has to be removed is more than 5, then the preceding number should be increased by 1. Suppose the number is 1.386 and we have to remove the rightmost digit, that is 6. Now this 6 is greater than 5. So what we should do is, while removing this 6, the number which is present before the 6 should be increased by 1 unit. That means 8 should become 9. So answer is 1.39. Did you understand? If the rightmost digit that has to be removed is greater than 5, then its preceding number should be increased by 1. If the rightmost digit that has to be removed is less than 5, for example 4.334 is less than 5, then its preceding number is not changed. That means the answer will be 4.33 only. Now, if the rightmost digit which has to be removed is equal to 5, then there are two conditions here. Now see, 6.35. Okay, this 5 we have to remove. First, we have to see what is the nature of that preceding number, whether it is odd or even. If it is odd, here 3 is an odd number, then it should be increased by 1 unit. So our answer will be 6.4. Suppose if it is even, then there is no change. Did you understand the rules? If the rightmost digit that has to be removed is more than 5, then its preceding number is increased by 1 unit. If the rightmost digit that has to be removed is less than 5, then there is no change in its preceding number. If the rightmost digit that has to be removed is equal to 5, then its preceding unit is increased by 1 if it is an odd number. If it is an even number, then there is no change. Okay. Now coming to the next most important topic, that is dimensional analysis. Let us see what is meant by dimensional analysis. Now students, coming to the next topic, that is dimensional analysis. This dimensional analysis is useful when we have to convert the units from one system to another. One system to another. Okay, the method to do this conversion is called either factor label method, or unit factor method, or it is called dimensional analysis. It is called dimensional analysis. Let us take few examples and try to understand it better. First example that we have taken is, suppose a piece of metal is 3 inches long. What is its length in centimeters? So we have to convert inches into centimeter. We know 1 inch is equal to 2.54 centimeters. 1 inch equal to how many centimeters? 2.54 centimeters. Now from this equivalence we can write 1 inch by 2.54 centimeters is equal to 1. Or we can write reverse also. 1 equal to 2.54 centimeters by 1 inch. Okay. Now since it is equal to 1, it is called unit factor method. Now for our conversion, what we have to convert is inches to centimeter. So say what unit we want in the result, that unit should be there in the numerator. Such a fraction you have to select. And how many inches we have to convert? 3. So 3 into 2.54 centimeters by 1 inch. We have to select. Why did we select this one instead of this one? Because if we select this one, our answer will come in inches. If we select this relation, then our answer will come in centimeters. In the question they have asked in centimeters. So that is why we have selected this fraction. And how many inches they have told us to convert? 3 inches. So 3 into 2.54 centimeters by 1 inch. Our answer will be 7.62 centimeters is our answer. Did you understand? Now let us take one more example. Next one is, a jug contains 2 liters of milk. Calculate the volume of milk in meter cube. So we have to convert liters into meter cube. The relation is 1 liter is equal to 1000 centimeter cube. But we want the answer in meters, no? So here you have to convert first 1 meter equal to 100 centimeters. So from this equivalence we can write 1 meter by 100 centimeters is equal to 1. Or we can write reverse also, no? 1 equal to 100 centimeters by 1 meter. But in the question they have asked in meter cube. So 1 meter cube by 100 centimeter cube is equal to 1 100 centimeter cube by 1 meter cube. Okay, now we want our result in meter cube. So our numerator should have meters. So we will deal with only this part. So 1 meter cube by 100 cube will be how much? 10 to the power 6 centimeter cube. Okay, 1 meter cube by 10 to the power 6 centimeter cube, that is 1 is equal to 1 cube. 1 cube is nothing but 1. Now what they have told, how much we have to multiply it with? They have told us to convert 2 liters of milk. So our answer will be 2 into 1 meter cube by 10 to the power 6 centimeter cube. Into 1000 centimeter cube. Okay, so what we have to do here, see here there are 6 zeros and here there are 3 zeros. So 3 zeros, and from 6 zeros 3 zeros will be cancelled. So here there will be 3. So 2 by centimeter cube cancelled, centimeter cube cancelled. 2 by 10 to the power 3 meter cube. Okay, when this 3 goes to the top, plus becomes minus. So 2 into 10 to the power minus 3 meter cube. Okay, did you understand? So this is the answer. 2 liters is equal to 2 into 10 to the power minus 3 meter cube. Now let us take one more example. Students, next question is very interesting. How many seconds are there in 2 days? So in 2 days, how many seconds are there? We have to calculate. Let us see how. 1 day is equal to, first we will see the hours. 1 day equal to 24 hours. So 1 day by 24 hours is equal to 1, which is equal to 24 hours by 1 day. Now hours we have to convert it into minutes. 1 hour is equal to 60 minutes. So 1 hour by 60 minutes is equal to 1, which is also equal to reverse. 60 minutes by 1 hour. Now this minute should be converted into seconds. 1 minute is equal to 60 seconds. So 1 minute by 60 seconds is equal to 1, which is equal to reverse of it. 60 seconds by 1 minute. Now what they have told, we have to convert 2 days into seconds. So we have to use these side relationships. So 2 into 24 hours by 1 day into, so if we have to get seconds, first we have to convert day into hours, then hours into minutes, then minutes into seconds. This minute gets cancelled, this hour gets cancelled. This is 2 days, no, this day gets cancelled. So we are left with 2 into 24 into 60 into 60 seconds, and this comes to 172,800 seconds. So this is our answer. Very easy. So to convert days into seconds, first we have to convert it into hours, then minutes, then seconds, and then just multiply it. So with this we have finished today's video. If you like the content of the video, if you understand the video, if you find this video useful in any way, please do like, share and subscribe, and don't forget to comment your suggestions on the video. If you have any doubts also, you can comment it below. Please feel free to comment your suggestions in the comment box. Thank you very much.